Newton's law of gravitation. Newton's law of gravitation. Gravitational force between two masses. Mass 1, mass 2. M1 and M2. Two masses. Distance of separation is R. That R is center of M1 to center of M2. Center of mass 1 to center of mass 2. The distance of separation is R. Then there is a existence of force which is attractive in nature. Force on 1 due to 2. That force is known as gravitational force. Magnitude of the force is directly proportional to product of two masses. And magnitude of the force is inversely proportional to square of the distance between two masses. You may take mod, or simply without vector sign you write F. Combining both equations, mod of F proportional to m1 m2 by r square. Equation 3. Then take the proportionality constant. That proportionality constant equal to G, capital G. This is the scalar form of Newton's gravitational force. What is G? Capital G is universal gravitational constant. What is this? Capital G? Universal gravitational constant. Universal gravitational constant whose value is 6.6 into 10 to the minus 11 unit. Force unit is Newton, multiply r square, Newton meter square per kg square. Newton meter square per kg square is the unit of universal gravitational constant. This is the what? Magnitude of gravitational force, right? Then force between two masses is directly proportional to product of the masses. Is inversely proportional to square of the distance between two masses. If you combine both mass, then F proportional to m1 m2 by r square, take the constant, F equal to G m1 m2 by r square. Magnitude of the force. Direction is force on 1 due to 2, G m1 m2 by r square, r1 to cap. Force is from 1 to 2, f1 to, if you mention f1 to, okay. This is the vector form, right? Then comes to properties of gravitational force. It is always attractive. Which force is both attractive and repulsive? Coulomb's, your electric force between two charges. Also Coulomb's magnetic force between two poles. But gravitational force is what? Is attractive. Force always between two masses. Number 1, it is always attractive. Number 2, force is conservative in nature. What do you mean by conservative force? Work done by this force is independent of distance. What? Distance. Suppose work is done from point O to P. If you go in semicircular path, it does not count the semicircular path. It will count, the distance will be count from O to P, the minimum distance. That is work done by the conservative force, path independent. So it is a conservative force. Attractive nature. Number 3, does not depend upon medium. In air medium, in water medium, in any medium, always gravitational force G m1 m2 by r square. Okay, Coulomb's force depends upon medium. Magnetic force as well as electric force. Okay, then Number one, attractive force. Number two, conservative in nature, conservative force. Number three, medium independent. Number four, obeys inverse square law because force is inversely proportional to square of the distance. Obeys inverse square law. Fifth one, long range force. Long range. Distance of separation is large. Existence of force. Distance of separation is small. There is existence of force. Okay. So which one is short range? Nuclear force. Nuclear force is the short range force. So it is a long range force. Then number one, attractive in nature. Number two, conservative force. Number three, what? Obeys inverse square law. Number four, medium independent. Number five, what? Number five, you say your gravitational force. Initially, you told attractive, always attractive. Second, inverse square law, follow the inverse square law. Conservative nature, medium independent, central force. From center to center, you take the distance. Central force, long range force. Okay. These are the properties of Newton's gravitational force. If you compare gravitational force and Coulomb's force of two protons, then it's a weak force. In comparison, Coulomb's force is larger, much larger than gravitational force. Nuclear force is also largest force. Okay, these are the properties of Coulomb's force.